In this video, we'll analyze the graph of this function h of x equals x cubed minus 125 over x squared minus 81 by finding its intercepts, asymptotes, critical points, and we'll sketch the graph. Okay, we'll start with factoring this function. Okay, so 125, we can see it as 5 cubed, so it's x cubed minus 5 cubed. We will use a difference of cubes formula, so that's x minus 5 times x squared plus 5x plus 25 over the bottom is x squared minus 9 squared. So difference of squares, x plus 9 times x minus 9. Nothing to cancel out here. We have no common factors. So we can say it's in lowest terms. So here we can determine its domain. The domain of h, you look at the denominator, right? X cannot be equal to negative 9 or 9, right? So the domain, you can say x is all real numbers but negative 9 and 9. This is one way to represent it. If you want to write it in the interval notation, you can say it's from negative infinity to negative 9, union negative 9 to 9, then union 9 to infinity. This also represents all real numbers but negative 9 and 9. For the intercepts, to find x-intercept, make y equal to 0, and you get 5, 0. That's your x-intercept. And your y-intercept is to make x equal to 0, and you will get 0, 125 over 8. Now let's look at the asymptotes. For vertical asymptotes, we will look at the denominator, which is x plus 9 and x minus 9. That will give us two vertical asymptotes. One is x equals negative 9, and the other one is x equals to 9. And since the degree of the top is 3, and degree of the bottom polynomial is 2, so that means we have an oblique asymptote because the degree of the top is 1 more than the degree of the bottom. So how to find oblique asymptote? We'll use long division. Okay, so we'll go x cubed here plus 0x squared, because we're missing the x squared term, plus 0x, also missing the x terms, then minus 125. Divided by the bottom denominator, x squared, missing the x term here, so plus 0x minus 81. Okay, so look at the terms, 1, 2, 3. So we go 1, 2, 3. All right, so the first term, or first number, comes above this 0x. We want to put a number or a expression here so that this times x squared will give us x cubed. So what times x squared is x cubed? X. All right, so x times x squared is x cubed. Keep going. X times 0x, that's 0x squared. X times negative 81, that's negative 81x. Okay, just like division, we draw a line, we subtract. So x cubed minus x cubed, 0. 0 minus 0 is 0. Now, 0x minus negative 81x is positive 81x. Right, drop the next term, minus 125, and you compare this with that. Since x squared minus 81 does not go into 81x minus 125, that will be the end of the division here, where this x is our quotient, which gives us the oblique asymptote, which is y equals x. That's our oblique asymptote. Okay, this 81x minus 125 is the remainder. So that means this expression, h, is equal to x plus 81x minus 125, this remainder divided by x squared minus 81, where this x is the y equals x is the oblique asymptote. Now let's sketch the graph. I first plot the x and y intercepts here, 5, 0 and 125 over 81. And now the asymptote, vertical asymptote, we have one at x equals -9. The other one at x equals 9. And we have oblique asymptote, which is y equals x. So we'll go like this. Here I want to do a calculation real quick to see our oblique asymptote actually intersect with our function h. So I will make a system of equation y equals x and y equals x cubed minus 125 over x squared minus 81, just to see if our graph will intersect the line y equals x. So use substitution, have x equals x cubed minus 125 over x squared minus 81. Do the calculation real quick. Okay, so solve the equation. You actually got 125 over 81. And plug in for y, that's the same. So actually the graph intersects the y equals x at 125 over 81, 125 over 81. So it's kind of right here. Okay. And this point is the only point where y equals x intercept our function h. Okay, now let's start graphing. First, we'll connect this. Naturally, we'll connect these points. Now, since the multiplicity for this x-intercept is 1, because x minus 5 only show up in the numerator once, so the graph will cross at this x-intercept. Instead of touching it, it will cross it and goes all the way down, because x equals 9 is a vertical asymptote. Now, the multiplicity for x equals to 9, this vertical asymptote, is 1, because this vertical asymptote only show up in the denominator once. Right? X minus 9 is only show up once. So the multiplicity is odd. That's why on one side it's going down, the other side will go all the way up to the infinity. Okay, now since our graph only intersects y equals x once, so as x goes to infinity, your graph will get closer and closer to y equals x, but never touch it again. All right, now let's keep going from here. We don't have another x-intercept, so obviously this will go up. Oh, since the multiplicity of for x minus x equals -9 is also odd, is also equal to 1. So since the right side is going up, the left side will go down. And similarly, we'll get closer and closer to y equals x, but never touches it. So this is basically how our graph look like for this function h.